The overall goal of this procedure is to synthesize ultra-small populations of biocompatible nanoparticles, characterize their physical properties, and investigate particle-cell interactions. This is accomplished by first using the phase inversion temperature method to synthesize the lipid nanoparticles. During this process, the lipid and surfactant are initially co-melted. After adding a specific amount of water, the mixture is heated until phase separation occurs. The mixture is then stirred continuously until a nanoemulsion is created and the synthesis of solid lipid nanoparticles, or SLNs, is complete. Next, dynamic light scattering, or DLS, is used to measure particle size and polydispersity. Differential scanning calorimetry, or DSC, is an additional technique used to determine the melting point and latent heat of melting in order to further characterize the particles. Ultimately, fluorescence microscopy and flow cytometry can be used to investigate the particle-cell interactions.
The main advantage of this technique over existing high-energy methods such as ultrasonication, microfluidization, and high-pressure homogenization is that this is a comparatively gentle synthesis technique which is both simple and scalable.
To synthesize the SLNs, combine 0.6 mg of fluorescent dye or other lipophilic compound and 0.10 grams of the linear alkane or lipid in a 15 ml vial. Co-melt the components at 90 degrees.